Imagine gazing up at the night sky. You see countless stars, each a distant sun. From here, they look like simple points of light. But what if I told you that some of them hide a secret? A truly mind-boggling secret. What if one of those stars was not just one star, but two? Not a binary system, with two stars dancing around each other. No, this is something far stranger. I'm talking about a star that has swallowed another star whole. A star living inside another star. This isn't science fiction. It's a theoretical possibility in our incredible universe. A cosmic nesting doll, where one stellar giant contains the crushed, dense heart of a long-dead star. This bizarre concept has a name. It is called a Thorne-Żytkow object, or TZO for short. Oh, think of it like this. You have a huge, puffy red supergiant star. It's enormous, thousands of times bigger than our own sun. Its outer layers are a swirling, fiery ocean of gas. Now picture a tiny, incredibly heavy neutron star. This is the collapsed core of a massive star that went supernova. It's only a few kilometers across, but weighs more than our sun. What happens if these two objects meet? In a strange cosmic dance, the giant star can engulf the tiny neutron star. The neutron star then sinks, spiraling down towards the center of its new, much larger home. The result is a hybrid celestial monster. On the outside, it looks almost like a normal red supergiant. A bit brighter perhaps, a little different in its chemical makeup, but inside it's a completely different beast. At its heart, the tiny superdense neutron star churns away. It's a gravitational powerhouse, disrupting the normal processes of the star around it. This star within a star is one of the most exotic and mysterious objects ever proposed by astronomers. It challenges our understanding of how stars live and die. The power of a TZO comes from accretion. The gas from the old red supergiant's envelope continuously falls onto the central neutron star. When this fast-moving material smashes onto the unyielding surface of the neutron star, its kinetic energy is converted into an enormous amount of heat and light. This process is fantastically efficient, far more so than nuclear fusion. The conditions here are so extreme that they trigger a unique set of nuclear reactions, the rapid proton capture process, or RP process. These freshly minted exotic elements don't just stay locked away in the core. The intense energy drives powerful convection currents throughout the star's interior, dredging up material from the core and mixing it throughout the star's envelope. Every great scientific story begins with a question. And the story of the Thorne-Żytkow object begins with two brilliant minds from opposite sides of the world. On one side, we have Kip Thorne, a giant in theoretical physics at Caltech. On the other side, we have Anna Żytkow, a talented astronomer from Poland who built her career at Cambridge, studying stellar evolution and the complex physics governing stellar interiors. Their collaboration began with a thought experiment. It was a simple what-if scenario. What if a neutron star found itself inside a living star, like a red giant? This wasn't just a random thought. They knew that as a massive star ages, it could swell up and completely engulf its smaller, denser companion in a process called common envelope evolution. They sat down and began to do the maths. They built complex computer models, simulating the intense physics of a neutron star suddenly finding itself at the heart of a star. The results were astonishing. They found that under certain conditions, the system could indeed find a new equilibrium. The Thorne-Żytkow object was born. In 1977, Kip Thorne and Anna Żytkow published their groundbreaking paper. It laid out in meticulous detail the physics behind their incredible idea and made a testable prediction. It described what one of these objects should look like to astronomers on Earth. This was the crucial step that moved the TZO from a mathematical curiosity into a real scientific target. For decades, that's where the story stalled. These objects could be hiding in plain sight, camouflaged amongst millions of ordinary red supergiants. How could anyone tell them apart? The answer lay in chemistry. The strange processes happening deep inside a TZO leave a unique chemical fingerprint, unusually high levels of lithium, molybdenum, and rubidium. The long wait finally came to an end in 2014. The breakthrough came from a team led by astronomer Emily Levesque at the University of Colorado Boulder. One star stood out, HV 2112, located in the Small Magellanic Cloud. When they examined its spectrum, they saw something extraordinary. The star's atmosphere was loaded with shockingly high levels of the predicted elements. So how does the universe build such a strange beast? The recipe requires specific ingredients and cosmic chance. It starts with two stars born together as a binary pair, locked in a gravitational dance. One star needs to be truly massive, more than 8 times the mass of our Sun. This star is destined to live fast and die young. The first key event happens when the massive star reaches the end of its life. Its core collapses catastrophically, and the star explodes in a brilliant, violent supernova. What's left behind is the star's crushed, collapsed core, a neutron star. A city-sized ball of matter so dense that a single teaspoon would weigh billions of tons. For a TZO to form, the system must survive this explosion. The neutron star and its companion must remain gravitationally bound, continuing their orbital dance. The surviving companion continues to evolve. It burns through its hydrogen fuel, and as it ages, it begins to swell up dramatically, becoming a red giant or supergiant. As it swells, it gets closer to its neutron star companion. The bloated red supergiant is on a collision course with the neutron star it has been dancing with for millions of years. The moment the red supergiant's outer layers touch the neutron star is the beginning of the end for the binary system. The neutron star spirals inward, eventually settling at the very center. A Thorne Żytkow object has been forged. To truly appreciate the weirdness of a TZO, it helps to see where it fits in the grand cosmic zoo of strange stars. Our universe is filled with celestial objects that defy simple classification. A white dwarf is the dead core of a sun-like star, supported by electron degeneracy pressure. A TZO represents a much more extreme state of matter, held up by neutron degeneracy pressure. Blue stragglers are found in old star clusters, appearing much younger than their neighbors. They're the result of stellar mergers or mass transfer, one star acting as a stellar vampire, siphoning gas from its companion. Cataclysmic variables show another form of stellar vampirism, where a white dwarf pulls material from a companion, leading to periodic thermonuclear explosions called novae. Magnetas are neutron stars with unimaginably powerful magnetic fields, quadrillions of times stronger than Earth's. Their magnetic fields can buckle the star's surface, causing starquakes that release colossal bursts of high-energy radiation. A TZO is defined by its strange hybrid nature. It's a red supergiant powered by a neutron star. It represents a story of merger, not just extreme physics. The hunt for these cosmic ghosts is a needle in a haystack problem. We need efficient ways to narrow down the search and pick out the most promising targets for closer examination. Large-scale astronomical surveys are mapping huge swathes of the sky. By cross-referencing these vast catalogues, astronomers can look for stars with unusual properties that might hint at a TZO. The future of the hunt relies on next-generation telescopes. The James Webb Space Telescope and upcoming Extremely Large Telescope will give us unprecedented views of the cosmos. These powerful new eyes will allow us to get exquisitely detailed spectra from stars in nearby galaxies with unprecedented speed and clarity. They'll be the ultimate tools for hunting down these cosmic ghosts. Many questions remain. Are they real? How long do they survive? What happens when they die? Could they be responsible for creating some of the rarest heavy elements in the universe? Answering these questions requires more detailed observations and sophisticated computer simulations. Each new element detected adds another clue to the mystery. Why do astronomers get so excited about TZOs? These objects are natural laboratories for exploring extreme physics. Inside a TZO, matter exists under conditions we could never replicate on Earth. By observing a TZO, we can test our understanding of fundamental physics. Our theories of gravity make precise predictions about how matter should behave in such intense gravitational fields. TZOs are unique testing grounds for nuclear physics. The strange nucleosynthesis happening on the neutron core surface is a pathway for creating heavy elements that's not well understood. They are cosmic alchemy engines. By observing them, we learn about our own origins, tracing the elements in our bodies back to the fiery hearts of stars, including these strange, hybrid ones. These objects force us to rethink the very definition of a star. We tend to think of stars as simple balls of gas powered by nuclear fusion. TZOs show us the universe is far more creative than that. They demonstrate that a star can be a complex hybrid object powered by gravity itself. This expands our understanding of stellar evolution, revealing a rare but possible pathway in the lives of binary stars. So, where do we go from here? The discovery of HV 2112 was not an ending, but a beginning. The hunt is now more focused than ever before. This continuing quest will be powered by incredible new technology. We are standing on the brink of a new era of discovery, where these once hypothetical objects might become a regular part of our stellar catalogue. Every time you look up at the night sky, remember the story of the Thorne Żytkow object. Remember that among those serene points of light, there may be celestial monsters hiding in plain sight. The universe is not a static, quiet place. It is a dynamic and violent arena of creation and destruction, where stars collide, merge, and transform into things beyond our wildest dreams. The sky above you is filled with secrets, and we have only just begun to scratch the surface. The journey of science is about asking questions, seeking answers, and never being satisfied that we know it all. The secret life of stars is one of the grandest mysteries we can explore, and the Thorne Żytkow object is one of its most compelling chapters. It encourages us to keep looking, to keep questioning, and to keep wondering. Because the next great cosmic discovery might just be hidden in the next spectrum we take, waiting for a curious mind to notice that something is just a little bit different. The adventure continues.